the root locus of the system is given, okay, where k is greater than 0 enters into real axis. What is enters into real axis mean? There is some real axis like this, okay, my root locus is entering that real axis like this, which is nothing but this is my break-in point. So we need to find break-in point. Which is the break-in point from these particular equations we need to see, okay. Before that, let us construct the root locus for these equations, okay. First step, the equation given is s square plus 6k s plus 2s plus 5 is equals to 0, okay. This is the first step. Let us determine it with k f of s form. So dividing both sides by s square plus 2s plus 5, this part and this part, this part and this part, we are going to get 6k s by s square plus 2s plus 5 is equals to 0, and this will be divided, so we are going to get 1 plus, okay. What is my f of s here? 1 plus, so we are going to get f of 1 plus f of s is equals to 0 only, so it will be DRL only, because all s coefficients are positive only. Next, second step is from f of s. What is my f of s? F of s is equals to 6s by s square plus 2s plus 5, okay. 6 is my gain here. There is nothing to do with this point, it is just a transfer function. So we need to find the pole, okay. What are my poles here? How many number of poles would be? 2 number of poles. What all are they? We need to solve this equation. We'll solve this. How many number of zeros are there? 1 0. What is the 0? Value of 0? 0. Okay. Solving this equation, s square plus 2s plus 5 is equals to 0. Okay. Minus b. We'll solve using algebraic equation only. Minus b plus or minus root b square is 2 square is 4 minus 4 into b square minus 4 into what is the value of a? B square minus 4 into a, 1 into c, 5 by 2 into a, okay. So s value will be minus 2 plus or minus root of 4 minus 4 5s are 20 divided by 2, okay. Okay, so from this we are going to get s is equals to minus 2 plus or minus root of minus 16 by 2. S is equals to minus 16 is nothing but 4j, okay. So minus 2 plus or minus 4j by 2. Again we are solving this, we are going to get 2 is divided, so minus 1 plus or minus 2j. These both are my poles, okay. So one pole is minus 1 plus 2j, comma minus 1 minus 2j, okay. These both are my poles and 0 is one of my 0. Next, let us see, there is no need of centroid. When it is not required, we need not find, okay. So let us draw the pole 0 diagram now. Drawing the pole 0 diagram, we will get sigma at this particular point and j omega. So 0 is my 0, so it will be here, and where is my minus 1 plus 2 is nothing but here somewhere we'll have minus 1 and plus 2j, so somewhere here there will be plus 2 and here it will be minus 2. So in this particular range, so here I will have my poles exactly, okay. This is the particular point where my poles are existing. Now we will see where my DRL is going to exist. Same process for every of the root locus finding point. The required solution, what they need is would be different, like finding the gain, finding the breakaway point, finding the break-in point, but the process we need to follow would be the same. So let us see where the DRL exists. So from seeing from this side of poles, we would have 1 2 3 poles, so DRL exists here. Again, seeing after this poles also, there is 1 pole, so 3 poles 1 pole, odd, so DRL again exists here. So this whole region till from negative half of 0, DRL exists, okay. again after 0 it does not exist because there are no poles and no zeros. Now we need to find break-in point. So we know the break-in point would be in such a way that the poles somewhere from open loop poles we are going to get towards the 0. So here is my 0. So somewhere here we are going to get the break-in point. So let us solve the equation first. So what is the f of s equation? K f of s 1 plus k into f of s is equals to 0. So I am sending here 1. K is equals to minus 1 by f of s. Okay. So k is equals to minus of, what would be my f of s? 1 by f of s is nothing but what is my f of s? 6s by s square plus 2s plus 5. 6s by s square plus 2s plus 5. Okay, this is my f of s value. So let us invert this. K would be equals to minus of s square plus 2s plus 5 whole divided by 6s. What is the formula for finding break point? dk by ds should be equals to 0. Okay. Next, what are we going to do here? Let us differentiate. Same u by v method. We are going to get dk by ds is equals to v. What is my v here? See, I'm writing for reference again. U by v. Okay. So here I'm gonna get, what is my v? 6s into v u dash. So 2s plus 2 and 5 differentiation is 0 minus u. What is my u value? S square plus 2s plus 5. 6s differentiation v dash. So 6 whole divided by v square. What is the v square? 6s whole square is equals to 0. There is no use of this denominator because however it is going to multiply with the 0. Okay. Now solving this, we are going to get 6 to the 12. So 12s square, 6 to the 12s plus 12s. Again here minus s square minus 2s. Again minus multiplied with 5. Oh, 1 minute. Here there is 6 also. Sorry. So here it is 6 to the 12s square plus 12. Again it is multiplied with 6 and minus also. So let us assume minus 6. So minus 6s square and 6 into 12 is 6 to the 12 and minus 6. So minus 12s. 6 5 is 30 and 2 minus. So minus 30. Minus 30 is equals to 0. Okay. This is the equation. Let us solve this. 12s square minus 6s square is 6s square plus 12s minus 12s are getting cancelled and minus 30 is equals to 0. Okay. 6s square is equals to 30. 6 1 6 5s. So s square is equals to 5. S is equals to plus or minus root 5. What is the value of plus or minus root 5? Root 5 value would be 2.236. Okay. So the value of s would be plus or minus 2.236. Okay. In this both any one of would be my breakpoint. How I will determine that? Based on the DRL. So here my DRL exists, there my DRL doesn't exist. So where is my root 5 value? Somewhere here, root 5 plus root 5 and minus root 5 would be somewhere here, minus root 5. So which position for this particular point the DRL exists? So what is my answer? S is equals to minus root 5 is my actual break point. Okay, break away point. It would break point. We can, as per this, entering into the real axis. So this could be my break in point. Okay. Next question. Okay, coming to the Bode plot problems. A Bode plot represents. What does a Bode plot really represent? Pole zero locations. We have done through pole zero diagram. So this is not the option. Stability margin only? No. Through the stability margin, we can directly draw the pole zero diagram, and if the poles are to the right half, to the left half of the S-plane, we can directly tell stability margin and stability cases. So this is also not the time response of the system. No, time response plot directly gives time response of the system. This is also not right. What is the right answer? Frequency response. We are going to the frequency analysis in the Bode or Nyquist or polar plot exactly. Okay. Next question. In Bode plot, frequency is usually represented on, what is the scale we are going to use in the Bode plot? Never forget this. Students get confused between these both, so this is not the right option. Normalized scale, there is nothing to do with this. Linear or logarithmic scale only. Logarithmic is the direct option you need to see when we are dealing with Bode plots at particular which scale diagram we are using. So this is the logarithmic scale. Next question. In Bode magnitude plot, okay, some Bode magnitude plot is there. The slope of the asymptotic magnitude curve changes by plus 20. How much? Plus 20 dB per decade. When it is the slope change is of plus 20 dB per decade. Okay, dB per decade. Then, which of the following elements in the transfer function causes this thing? What is the change due to a pole? When a pole is going to change, then there will be a slope change of minus 20. But when a 0 is going to change, plus 20. 0 is going to change, it is plus 20. When two poles are changing, it is minus 40. When two zeros are changing, it is plus 40. In this particular case, plus 20. So what is the option? A 0 at that frequency is exactly the option. So when it is a 0, we are going to get plus 20. When it is a pole, we are going to get minus 20. A double pole, we are going to get minus 40. Okay, there is nothing to do with this integrator. Okay, understood, students? Next question. This is not 26, it is 20. Okay, 20, 40. Okay, next question. 3 dB bandwidth of a typical second order system with transfer function C of s by R of s is given. Okay, it is a standard representation of a transfer function. Then we need the 3 dB bandwidth. Okay, from the options we could see omega n by, this is half baked kind of option. So this wouldn't be the option at all. Okay, next option, omega n into root of 1 minus zeta square plus root of zeta power 4 minus 2 zeta square plus 1. This could be the right option, but never forget 4. 4 is the variable which in this direct formula based question this is. Okay, so this in this particular point, this is not the right option. Students may get confused here only. The value between this 1 minus 2 zeta square and root of 4 zeta power 4 minus 4 zeta square plus 2, here we need to have plus, not minus. So this is the wrong option. This is the right option. Okay, plus is only the correct. Here we need to have plus, not minus. Okay, this is a direct formula based thing. Okay, next question. So some system is given. In the input x of t equals to sin t in the steady state, and the response y of t will be. Okay, we need to find the output directly. So let us follow the frequency response analysis. Through frequency response analysis, let us do this problem. Okay, what is my g of s? My g of s is given as s by s plus 1. Okay, let us substitute g of j omega is equals to j omega by j omega plus 1. Okay, this is the first step we are going to do. Already we have x of t is equals to sin t. From this, it is of the form sin omega t, where my value of omega is equals to 1. So put this value here. Understood? So when we are going to put 1, j by j plus 1 g of j omega. Okay, this is the particular point. This is the first preliminary first equation which we are going to get. Now we will find the amplitude and phase of this problem, phase of this transfer function representing in amplitude phase form. Okay, g of j omega mod is equals to however here 0 plus 1 square whole divided by root of imaginary square, real square plus imaginary square, 1 square plus imaginary square is 1 square. Here I am going to get 1 by root 2. Okay, this is my amplitude. What is my angle? Angle of g of j omega is equals to, firstly, what is the angle here? Tan inverse of y by x. Y is nothing but coefficient of imaginary. What is imaginary coefficient? 1, and real coefficient is 0. Okay, minus Why minus? In the denominator, we are multiplying denominator, making into numerator, so we are getting minus. Again, tan inverse of, here, j. For j, we are going to imaginary part, the coefficient is 1, and real part also coefficient 1. Okay, 1 by 0 is nothing but tan inverse of infinity. Tan inverse of infinity is nothing but 90 degrees. Minus tan inverse of 1 by 1 is tan inverse of 1. What is tan inverse of 1? 45. 45 degrees. So what is the answer I'm gonna get? 45 degrees. So what is my phase and amplitude here? 1 by root 2 and 45 degrees. So this g of s is represented as, g of j omega is represented as 1 by root 2 angle 45 degrees. Okay. So g of j omega is equals to 1 by root 2 angle 45 degrees. What is my x of t already? Sin t. What do I required? Y of t. What is the value of y of t actually? My input x of t into my output h of t. Okay. In terms of LTI system. Okay. So x of t. What is the value of x of t? Sin t. And what is the value of h of t or g of j omega t, whatever it could be? We represented it as in see 1 by root 2 angle 45 degrees. We represent it in the polar form. Okay. 1 by root 2 angle 45 degrees. Okay. So multiplying this here, we are going to get so 1 by root 2 is the amplitude. So we are going to get at the starting 1 by root 2 and sine of, what does this t actually represent? The angle. So what is the angle? Already we have for some that actual LTI input inside 45 degrees. So it is a positive 45 degrees. So t plus 45 degrees. Y of t. This is the value of my actual output in frequency response form. Okay. This is the, it is a time response analysis only, but we have did it using frequency response analysis. Okay. Solution type. So as per the options, option B is my right answer. Okay. Moving forward to next question. So the next question, a system has 14 poles. Okay. The number of poles 14, 2 zeros, number of zeros 2. Okay. High frequency asymptotic in a magnitude plot having slope. What is my slope? We have already discussed. One pole. Okay, one pole minus 20 dB per decade. 1 0 plus 20 dB per decade. Okay. How many poles? 14 poles. So minus 280 dB per decade, and how many zeros? 2 zeros. So plus 40 dB per decade. What I am gonna get? Minus 240 dB per decade. As simple as it is. Very easy question. Just the logic is how many number of poles and how many number of zeros are given. For one pole, how much is my slope change? For n number of poles, how much is my slope change? For the whole plot, what will be my final slope? So for my final slope, the option would be minus 240 because 14 poles are there. So obviously negative only. 2 zeros, just a scale up of 40 dB per decade only, plus 40 only. So 280 minus 40, we are going to get 240, minus 240. Okay. Next question. In the Bode plot of a unity feedback control system, the value of phase of g of j omega at the gain crossover frequency is minus 125 degrees, which is nothing but pi. The value of pi is given as minus 125 degrees. We need the phase margin. Simple question. This was asked in the previous GENCO-TRANSCO exams. Okay, directly finding the phase margin from the given transfer function or directly from the what we say phase of the system. What is the value of phase margin? 180 plus pi. Okay, 180 minus 125. What is the answer we are going to get? 55 degrees. Okay, 180 plus pi is the formula for phase margin. So 180 minus 125 is 55 degrees. So option C is my right answer. Okay, next question. Okay, the open loop transfer function of a unity feedback system is given. The gain crossover frequencies in the system are respectively. What is this gain crossover frequency? Is nothing but we need to find the value of omega exactly. So to find the value of omega, okay, we need to firstly substitute s with j omega and equate it, the mod of j omega should be taken and equated to 1, and from there we will find the omega at that particular point. Okay, so let us proceed with the options. Okay, some similar options are there, no need to worry, we'll see. So g of s is equals to 3 by s of s plus 2. Okay, g of j omega is equals to 3 by j omega into j omega plus 2. Okay, this is the first one. Okay, next what we need to do, we need to take the mod of this equation. So g of j omega should be equated to 1. Okay, we need to equate to 1. So equating that, g of j omega mod is equals to, in the numerator however we are going to get 3, in the denominator we are going to get omega square, so omega only here. Okay, next square root of, again here real square, 2 2s are 4 plus omega square, and this whole value is equals to 1. Okay, so what will be here, square and square root gets cancelled and this will be sent that side. So 3 is equals to omega into root of 4 plus omega square. Okay, let me take squaring on both sides. So I'm gonna get 3 3s are 9 is equals to, here the step is squaring on both sides. Okay, squaring on both sides. So 9 will be equals to omega square into 4 plus omega square. Okay, till this it is fine. Now let us multiply them. 9 is okay, this I'll write in the next page. 9 is equals to omega square into 4 plus omega square. Okay, again square 4 plus omega square, right option. So multiply them. 9 is equals to 4 omega, nine is equals to 4 omega square plus omega power 4. Let us assume omega square is equals to a not 9, a. Okay, so 9 is equals to 4a plus a square. Okay, omega power 4, so omega square, so a square. So we will get a square plus 4a minus 9 is equals to 0. Let us solve this equation first. By solving this equation we are going to get, so we will follow the steps only again. Minus 4 plus or minus root 4 square, 16 minus 4 into, what is my a value, 1 into c, minus 9 by 2 into a. So a I am going to get minus 4 plus or minus 16 into minus is plus, 9 4s are, it is 36 whole divided by 2. So here I will get minus 4 plus or minus 52 by 2. By solving this we will see what is the value of a. So I am going to get value of a as minus 4 plus root 52 by 2. The value is 1.60 comma minus 4 minus root 52 by 2 minus 5.60. Okay, this is the value of a, not the value of omega. We need to find the value of a. What value of omega? So what is the value of omega? Omega is nothing but, omega square is nothing but a, then omega is nothing but square root of a. So first 1 omega would be square root of minus 1.60, sorry, 1.60. Okay, this will get some value, and one more omega would be minus square root of minus 5.60. This would be a j, some value, say j and some value, so it is imaginary. So this is not the right value, but 1.60 would be the square root of 1.60 will be 1.26. So square root of 1.60 is 1.26. So as per the options, yes, D is the right answer. Omega is equals to 1.26 is the correct option. This is the right answer. Okay, in this way we are finding the gain crossover frequency for the given system. Okay, understood, students? Next question. The phase margin of a system having loop transfer function is given. We need the phase margin. To find the phase margin, we also need the gain margin. Why? I will tell you. Let us follow the steps properly. We'll find the gain margin and we'll find go through the phase margin next. So firstly, given GH, simplified motion I'm writing in simple way. GH is equals to 2 root 3 by S of S plus 1. Okay, let us find the mod of this. Like, let us substitute G of j omega into H of G of j omega, H of j omega is equals to 2 root 3 by j omega into j omega plus 1. So this is my first step. Next step, I'll take the magnitude. Okay, for magnitude, mod of GH mod is equals to 1. Okay, from this 2 root 3, however it is constant, would be the same thing. J omega would be omega. Okay, omega square, whole root again, square or root cancel. Next, here I'm going to get omega square plus 1 square. This will be equals to 1. So multiply this that side. 2 root 3 is equals to omega root of omega square plus 1. Okay, this is the first thing. Squaring on both sides here at this particular point. Squaring on both sides. So 2 2s are 4 into 3, however it root goes, and this is omega square and this is omega square plus 1. Okay, this is the first thing. Next thing, 4 3s are, it is 12. Omega square is multiplied inside, so omega power 4 plus omega square. So resolving this, we will get omega power 4 plus omega square minus 12 is equals to 0. So, okay, this is the equation which I have got from this process. I hope everyone understood this thing. Like, I have just divided, like I have multiplied this way, and then combined it, square. I have done squaring on both sides, then I have got this last equation. From this point, I will directly solve this. See, omega power 4 plus omega square can be written as omega square can be written as 3. I think this would be minus. 1 minute. Okay, right. 4 omega square minus 3 omega square minus 12 is equals to 0. Okay, we can write it as this way, right? 4 omega square minus 3 omega square is omega square, and 4 into 3 is 4 into minus 3 is minus 12 omega 4, which is the similar as minus 12 omega 4. Okay, directly I have taken the simplified version. So from this I'll take common omega square. Okay, then I'm get omega square plus 4. From this both I'll take common as omega minus 3. Then I'll get omega square plus 3 4s are 12, so 4 is equals to 0, which will be omega square plus 4 into omega square plus 3. Okay, next, omega square plus 4 is equals to 0. Okay, this I'll write in the next page. Okay, here we can write. Okay, next, 4 into omega square plus 3. Omega square plus 4 into omega square plus 3. sorry, minus, I think something is minus. Minus 3. Okay, this is not plus, this is minus. Omega square minus 3. Okay, minus 3. So omega square plus 4 is equals to 0. Omega square is equals to minus 4. Omega equals to minus 4 whole root. Omega equals to plus or minus 2j. This is one possibility. Next possibility, omega square is equals to 3. Omega equals to plus or minus root 3. This is one possibility. This is one possibility of omega. Okay, maximum imaginary won't be considered. Real part is only considered for omega value here. So now we need to find the phase. First, our actual outcome is phase, but why we will find omega, I will tell now. So what is my equation? GH is equals to 2 root 3 by S of S plus 1. Okay. Now finding angle GH. For finding angle, we are going here, however, imaginary part is 0. So tan inverse of 0 by 2 root 3. This is the first one. Next, minus of. Here S is nothing but J omega. What is the value of omega there? Root 3. I won't consider it as minus root 3. Let us keep minus aside. Let us consider it as plus root 3 only. Okay. So here we'll get tan inverse of J omega. So omega value is root 3. So root 3 divided by, what is my here, the value of real part is 0. Again minus. This is also minus. This is also minus when it's coming to phase. Okay, again here for J omega, my omega value is root 3. So tan inverse of, sorry, root 3 by 1. Okay, this is my phase equation. Now from here, what is the answer I am gonna get next? First, tan inverse of 0 is angle of GH is equals to 0. First tan, then minus 0 by 1 is minus 90 degrees. Again it is minus tan root 3. What is tan inverse of root 3 value? 60 degrees. Okay, exactly it is 60 degrees. So which we are going to get? Minus 90 minus 60 is exactly minus 150 degrees. So PM, what is the value of PM? 180 plus pi. This is the value of pi actually. Okay, not PM, phi. We need phase margin. So 180 minus 150. The answer is 30 degrees. 30 degrees is the right answer. In this option there is no 150. So students may not get confused. Suppose in the place of this option, if there is 150 or minus 150, many students will get confused and directly put that as option. But that is not the thing. We need phase margin PM, not the phase angle. Okay, understood students? Next question. So a non-minimum phase transfer function is defined as the transfer function. Non-minimum phase system we have discussed in the previous problems also. In the time response time, non-minimum phase is nothing but the phase, it is not particularly stable, that it is not stable. Okay, when it is not stable, what is the conditions we have? Either after the point of 0, which is exactly at origin, after the origin, here RHP poles should lie, poles, then the system is totally unstable. So what is my non-minimum phase system? Is unstable system. Which has zeros in the right half of S plane? Right answer. Which has zeros in the left half of S plane? No. If it is left half of S plane, it is stable system. Which has poles on right half of S plane? Yes. In the poles in the right half of S plane also, if the poles are going to exist, then it is also a non-minimum phase system. Which has poles on the left half of S plane? No. When it is the left half, then the system is stable, not unstable. Okay. Next question. Okay. In Bode magnitude plot, which one of the following slopes would be exhibited at high frequencies by fourth order all pole system? Okay, fourth order all pole system is nothing but, he is telling, now let us consider H of J omega is my system. transfer function name. Okay. Next, what happens is high frequency by fourth order all poles. For now, I am assuming S is equals to 0 as my pole, and fourth order in the sense I have 4 poles. Okay, there may be some or the other poles, but I will consider as 4 poles at 0 only. Okay, at origin only. So 0, 0, 0 and 0, 4 poles. So how I will represent in a transfer function? It has 1 by s power 4. Okay. So h of j omega is directly proportional to 1 by s power 4 if s is equals to 0. I am considering, let us consider for some time. Why directly proportional? There would be some k constant or some other 0 in that. But here there is a fourth order pole. So here what we have learnt, one pole minus 20 dB per decade. Okay. 4 poles, 4 into 20 is minus 80 dB per decade. Understood, students? So from my options, minus 80 dB per decade is the right answer. Simple question. Fourth order pole in the sense my order of pole is 4. Okay. When it is 4 into minus 20, minus 80. Simple question. Okay. Next question. Coming to the Nyquist. Nyquist stability criteria relates the number of encirclements of the point. Which point? Nyquist totally deals with only minus 1 and 0, minus 1 comma 0. How many encirclements in the clockwise, how many encirclements in the anti-clockwise, everything deals with minus 1 comma j0 only. Understood, students? Simple question. This was asked in the previous AE exams also. Just remember this one point, you can solve any Nyquist problem easily. Next question. So a differentiator as a transfer function. Firstly, we need to know what is a differentiator. So the differentiator is nothing but we will give some input. Okay, x is my input, y is my output. Okay, so in between whatever I give, it is just need to differentiate. Differentiate in the sense d by ds. What is going to add a d by ds in Laplace transform wise of a s? You understood, right? We have if we are going to take d by dt of y of t, okay, y of t, okay, then we are going to find the Laplace transform of this. What are we going to get? S into y of s, which is nothing but s is my differentiator element. Yes or no? So here I will get s. So what is the transfer function of differentiator? Directly it is s. Please remember this from now. Okay, what is the transfer function of differentiator? S. What is the transfer function of integrator? 1 by s. That's it. There is no confusion in this. So as per this, he is asking what increases constantly or what decreases, phase or amplitude. Let us find this easily. First let us go with the amplitude. Mod of g would be s is equals to j omega. So j omega I will put, and if I am going to take mod of this, I am going to get omega. Okay, this is my amplitude. Secondly, what is my phase? So angle of g would be angle of j omega. What is the angle of j omega? Tan inverse of, okay, what is my value? Omega by 0. What is tan inverse of omega by 0? Infinity. What is tan inverse of infinity? 90 degrees. Okay, so my phase is constant. Phase is constant, but amplitude varies. Understood? Phase is constant but amplitude varies. How it varies? We'll see by the options. Like omega is going to vary upward or downward. Okay, phase increases. No, phase does not increases. Amplitude remains constant. No, amplitude does not remain constant. Amplitude increases linearly with frequency. This could be the right answer. Okay, amplitude decreases linearly with frequency. This could also be the right answer. But when phase is constant, okay, my phase is constant, amplitude is going to just increase, not decrease. So amplitude will not decrease. phase is constant, amplitude is going to increase only. Okay, simple question. Just remember with the differentiator, this is the point where many phase questions, phase lag, phase lead in the compensators, controllers, these type of questions are asked. Okay, next. The Nyquist plot of an open loop transfer function GH of a system encloses the -1, 0 point. The gain margin of the system would be gain margin GM. This is a direct question. When something is encircling what? My Nyquist plot is encircled by, Nyquist plot is encircled at the point of -1, 0. Okay, not around -1, 0. If this is -1, 0, so my Nyquist plot is encircling something like this. Okay, it is encircling. So how my gain margin is going to be? Obviously, it is not 0, it is not infinity. It would be less than 0 or greater than 0. If it is less than 0, it will encircle -1, 0 like this, either in the clockwise or anti-clockwise, some or the other direction. But if it is greater than 0 only on this particular point and in anti-clockwise direction only, it is going to encircle. Okay, this is the main difference between both, less than 0 or greater than 0 of the gain margin. So A is the wrong option. Option C is only the right answer here. Simple question, just a small basic thing. Okay, next question.